Day, folks. Welcome to my YouTube channel. This is a question on electric circuits. It's a June 2022. It's a national paper, right? Let's cut the chase. Now it says in the circuit below, a battery of an unknown EMF and an internal resistance of 0.5 were given there, and is connected to two resistors, 4 ohms and 8 ohm each, and resistor R of an unknown resistance. If you look there, we have two lines that are parallel, and we have a series in that line that is parallel, which is the 4 ohm and the 8 ohm resistor. The 4 ohm and the 8 ohm resistor, the combination is parallel to R. Ignore the resistance of the connecting wire. Now guys, let's look at in a case where the circuit is closed. If the circuit is closed, the current will move from this direction. When it gets there, there's a splitter that going in that direction, and there's a split that is going there, and then they combine and go there. If the switch is open, so the current will only go this way, right? Let's answer 8.1. 8.1, it says the three external resistors are ohmic conductor. Explain the meaning of the term ohmic conductor, which is the three external conductors, which is resistors. This and this are ohmic conductor. So the guys, the resistors that are ohmic conductor, that means they obey Ohm's law. That's simple as that. So the resistors, they obey Ohm's law, or you can say the potential difference in the current is directly proportional at constant temperature, or you can say the ratio which is I divided by V, which is the resistance, is what is constant. The ratio is what is constant. It's constant where? It's constant at constant temperature. At constant temperature. Guys, I didn't write the other explanation, right? Okay, let's go to 8.2. It says the switch S is open, just like this. This switch is open, so the effective resistors are those ones. The current is not going to go there. It says when switch S is open, the V1 reads 3.2, which is this one. So the voltage here is 3.2. Doesn't mean this one is 3.2. These two are series, so whatever the total of the voltage here is divided, the other division is 3.2. So let me write it there. So we have 3.2 volts there. Now it says calculate the current through the battery. So guys, if we have the voltage, the potential difference here, and we have a resistance, we can calculate the current that passes there. So this resistor have the same current with that one, so we can say I is equal to V over R, and then we take the voltage is 3.2, and we divide by the resistance, which is 4. It's going to be 0.8 ohms amperes, sorry. Now 8.2.2, calculate the EMF of the battery. So guys, the EMF of the battery does not change, and the internal resistance here. So calculating the EMF, we use the formula EMF is equal to I into R plus R, close bracket. So calculating we'll take the 0.8, guys, is the total current. That's the total current that passes there, right? It's going to be 0.8, and then in the external resistance, the external resistance is the sum of these two because they are in series. So the circuit, it only has series, so it's going to be 8 plus 4, and then we say plus, in the internal resistance it's 0.5. That's the external resistance. This is internal, and this is the external. So the answer there, it's going to be what? 10 volts. I hope that, guys, that makes sense. Now in 8.3, it says the switch S is closed. The V2 reading reads 8.8. When this switch is closed, the V2 reading reads what? 8.8. So what does it mean by this 8.8? Since there's a current, there, there's a current that is moving here and the other is going there, and then they combine there. So this 8.8, that's the V external, it's the V load, in other words. Now the question, it says calculate the resistance R. Remember, the 8.8 is the resistance of the load that is used externally. So what are we going to do? The first thing that I'm going to do, I'm going to calculate the internal resistance. Okay, this is 8.3.1. The first thing that I'm going to do, I'm going to calculate the internal resistance. The internal resistance here, we use the formula that says V internal is equal to EMF minus the V external, because we do have the sorry, we do have the EMF, which is 10, and the external is 8.8. So the answer there, it will be 1.2 volts. So having the V internal, I can simply calculate the total current, because the current, we do not know what is the new current. So the current that we had, it was a current for only these two resistors. So when we add this one, the total resistance decreases, the current increases. So we'll have a bigger current than this now, because we added a resistor in parallel there. So let me calculate the total current. I'll say V internal is equal to IR, and then the V internal is 1.2, and the total current and the internal resistance there. So I is going to, when you punch that in the calculator, it will give you 2.4. 1.2, it will be 2.4 amperes. Sorry. Having that total current, so what I can do with that total current, I can use it to get the external resistance, because here externally there's a total current, the one that splits there and it combine, it's a total current. So the next thing that I'm going to do, I'm going to find the R external using that formula. So this is R external using the V external, and using the total current, which is the current that is externally. So what I'm going to do, the V external is 8.8, and then I divide by the current, which is 2.4, and then my answer there, when I punch that in the calculator, I'll get a 3.67 ohms. That's the total resistance of the external. This is the sum of these two. Even though we do not know this, the question, it requires this. So now having that, I'll say the R external is equal to the R parallel. Remember, this is only parallel the external circuit. So what I'm going to do, I'm going to label these resistors. I'm going to say this is resistor 1, and this is resistor 2, and this is resistor 3, right? So I'll say 1 over parallel is equal to sorry, remember, these two, they are in series in the parallel, so I'll add 2 and 3 together and make them parallel to this one. The total of this, I'll make it parallel to this one. It's 2 and 3. So I'll have R1 plus R2 plus R3 and 1. So the R parallel is 1,36, right? So the R parallel is 3.67, sorry, that's 3.67, and 1 over the R1 is the R, the 1 is an unknown, I'll just put R, and then 1 over R2 is 4, and R3 is 8. 4 plus 8, which is going to be 1 over R plus 1 over 12. 1 over 3.67, and then I'll have 3.67 1 over r is equal to 1.367 minus 1 over 12. I hope you get that, mates. But what do we want? We want r there. So we're going to make an inverse of that. So making r as an inverse, we're going to get 5.28 ohms. Right? We got the answer there. The answer here for this one, and this resistor is 5.28. Now the 8.3.2, it says the battery becomes heated when the V2 is replaced by a connecting wire. Explain your observation. So what is happening here? Having this circuit, right? Instead of using the voltmeter there, the voltmeter that we have here, the current doesn't go there, right? So we replace this voltmeter by a wire. We just put a wire there. So what's going to happen here? If we replace by that a wire, our circuit becomes short-circuited. So our circuit becomes short-circuited. 8.3.2. The circuit is short-circuited, right? Why is it short-circuited? The resistance there, all the current, since the current, it was going this way and then it splits and the other go there, they won't go there, they will straight go this way. So what's going to happen? The battery is going to be heated, so it's going to cause fire because there's a greater current that is going there with a lower resistance. So what is happening? That causes the total resistance to what? To decrease. So if the total resistance decreases, the total current is going to increase in the circuit. So the battery here is going to receive a current, a greater current, a maximum current. That's why this is going to be heated. So if that's the case, we know the relationship. Between the current and the resistance. They are inversely proportional, right? So what is going to happen? Since they are inversely proportional, the total resistance decreases, the current will be very high. So we'll say here the current delivered by the battery, the current delivered by the battery will be very high, right? And then it causes fire. Guys, I hope that makes sense answering that question. Cheers. Bye.